Draw the shear and moment diagram for each member of the frame. To solve for this frame, we would have to solve the members individually. So we know A and B are fixed connections. So we're going to begin with member AB. Let's draw its free body diagram. So at member A, we're going to have both horizontal and vertical reactions plus the moment. Then we have 2-point loads, 6 kilonewton and another 6 kilonewton. At B, we can have same reactions as A, but I'm going to assume them opposite. Just looking at the reactions, I know that I won't be able to solve from this side. So we're going to have to begin with member BC before we get back to member AB. Because thing is, we can write the equations, but we won't get anything, and it just makes mess. Therefore, a good idea is to solve for member BC and then tackle this. So at member BC, we're going to have opposite reaction forces to member point B in member AB. Then our distributed load is 6 kilonewton, and converting into point load, it's going to be half times 6 times 3, which is 9 kilonewton. And that is it. Now to start solving, if we sum the forces in y direction, you're going to have positive Vy and negative 9 kilonewton. Solving this, Vy is 9 kilonewton. And then we can sum the forces in x direction. And solve it for Px, it's going to be 0. And now we can take moment above the point B. So we're going to have clockwise moment B, and then we have clockwise 9 kilonewton. And it's going to be 1 meters away, all equals to 0. And our moment B is 9 kilonewton meter. Okay, now we can go back and solve for this. So now we already know all these forces. Moment B is 9 kilonewton meter. Vy is 9 kilonewton and Bx is 0 kilonewton. Now we can sum the forces in x direction, first of all, to find our solution for horizontal force at E. So we're going to have negative Ex positive 12 kilonewton equals to 0. And solve for Ax, we have 12 kilonewton. Similarly, we can have sum the forces in y direction. And we can have Ay positive negative By, which is 9 kilonewton, equals to 0. Ay is 9 kilonewton. And then we're going to sum the forces in y direction or take moment above the point A. And this is going to be 6 kilonewton clockwise, 1.5 meters away. Then we have another 6 kilonewton 3 meters away. And finally we have Bx, which is 0. And then we have counterclockwise moment at B. And we have counterclockwise moment at A, all equals to 0. Solving for moment A, we get our solution as 18 kilonewton meter. Alright, now that we have all the required forces, we can draw our shear and moment diagrams. For shear, we're going to begin with member AB. So Ax pushes us up 12 kilonewton. And then we get pushed down 6 kilonewton after 1.5 meters. And then we get another push down to 0 after 1.5 meters. And then nothing happens. for another 1.5 meters, and we remain at 0. And this is our section AB. Okay, and now for section BC, we get pushed up by By, which is 9 kilonewton. And then for 1 meter, pardon me, not 1 meter, over 3 meters, we get down to 0. And the curve is going to be concaving upward, second order curve. Alright, so that was our shear. And now for our moment, we're going to begin at 0 again. Pardon me, not at 0, because we have moment from A counterclockwise, so we're going to go downwards, negative 18. And from there we have this area first of all. So it's going to be 12 times 1.5, which is 18. So we come up to 0. And then we have this area, which is 6 times 1.5. And it takes us up 9 points. First order curve again. And then we have moment at B counterclockwise, so 9, and we come down to 0. This means our moment equation is correct, or curve is correct, and then we remain. We remain in place, and the only thing I did wrong is nothing's going to happen for 1.5 meters, and then we're going to come down to 0. All right. Okay, and then comes our section BC. For section BC, we have moment right away, and this moment is, I'm going to do it in blue so that, or actually I'll do it in green so that it differentiates. So we have clockwise moment B, and moment B was 9, so we're going to go up 9 again, and this time for, remember, BC. And from there we have this second order curve. Just notice this moment B should have been negative here, so this means this will be counterclockwise, this will be clockwise, that means this will be 36, and that would mean we'll have to redo our moment curve. Okay, alright, so we're gonna begin at negative 36, and let's see what we did wrong, because somehow earlier our moment equation got to 0 when it shouldn't have. So let's see, so 12 times 1.5 is 18, so we're gonna come up to 36, take away 18 is negative 18, so we come up to negative 18. And then we have 6 times 1.5, which is 9. So negative 18 plus 9 is negative 9. We come up to negative 9. And then we have clockwise. So clockwise is positive. We're going to flatline and go up. Oh, that worked out. Alright, so now that we have that done, now it's time for our second part. So for our second part, I'm going to use green color. And we have a counterclockwise moment. That means we're going to go downwards 9 kilonewton. We're going to come down here again, negative 9. And then we have this area, positive area, which is going to be area of the spandrel. So this is going to be base times height, so 9 times 3 divided by 3, and that comes up to be 9, positive 9. And so this curve is going to be concaving downwards. hence it's going to be third order.